Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 5 units, side AD equals to 3 units, side DC equals to 6 units, angle ADC equals to 90 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of side BC that is actually equals to x. So we start with the first method. In the first method, we will make a construction. We will extend side AB and side CD by a straight line until they intersect with each other. And we will define the intersection point of the extended side BA and the extended side CD as E. So here we created triangle EBC. In triangle EBC we have two angles that are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. And we have rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. So I'll write it down. In front of equal angles in the triangle there are equal sides. So I'll read rule number 1 again. According to rule number 1, in front of equal angles in the triangle there are equal sides. So here in triangle EBC, those two angles are equal to each other, they are both equal to theta, therefore side EC equals to side EB according to rule number 1. We'll write it down. Here, angle ABC, this angle, equals to this angle that is actually angle ECB. and both angles are equal to theta according to what is given in the question. I repeat again, angle EBC equals to angle ECB equals to theta according to what is given in the question. Therefore, we can conclude from it that according to rule number 1, sine EB equals to sine EC. Sine EB equals to sine EC. According to rule number 1, of course. This is the question number 1. Sine EB equals to 5 plus AE. While sine EC equals to 6 plus ED. So, according to equation number 1, 5 plus AE equals to 6 plus ED. We subtract 5 from this equation, equation number 1. And we will get that according to equation number 1, AE equals to 1 plus AD. According to equation number 1, AE equals to 1 plus ED. Here we define ED as A. So here AD equals to A according to our definition. Now we substitute ED by A in equation number 1, and we get that according to equation number 1, AE equals to 1 plus ED is A. So we found out that AE equals to 1 plus A. A equals to 1 plus A. So we can write here that AE equals to 1 plus A. Here, before we did the construction, we had the quadrilateral ABCD, and the line segment CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. CD is a straight line, and when we extended the straight line CD by straight line, the result is EC. That must be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line, therefore EC is a straight line. So you can write down that EC is a straight line. And we have rule number 2, according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So I write it down. I read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on this side, if you focus on this side of the straight line EC at point D, then the sum of the angles there must be equal to 180 degrees. So which angles we have? It's this side of the straight line EC at point D. Here we have 90 degrees. Plus this angle that is actually angle ADE. So in total the sum of those two angles must be equal to 180 degrees according to rule number 2, that is to say here 90 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. According to rule number 2, of course. Here we subtract 90 degrees from this equation and we get that the missing angle ADE is equal to 180 degrees minus 90 degrees, it is 90 degrees. So this angle ADE equals to 90 degrees. So if angle ADE equals to 90 degrees, it means that triangle ADE is right triangle. So we will implement the Pythagoras theorem on the right triangle, triangle ADE. The right green triangle, triangle ADE. And in this way we find out the value of A. Okay, so here, according to the Pythagoras theorem, in the right green triangle, triangle ADE, by PT, PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AE, so the square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus ED squared. I repeat again, according to the Pythagoras theorem, AE squared must be equal to AD squared plus ED squared. Here AE equals to 1 plus A, so we substitute AE by 1 plus A. If A equals to 1 plus A, it means that A squared equals to 1 plus A squared. And it is equal to AD squared plus ED squared. ED squared is A squared. So in conclusion, we found out that 1 plus A squared equals to AD squared plus A squared. We'll open the brackets on this side of equation number 2, and we'll get that according to equation number 2, one plus A squared equals to 1 plus A squared plus 2A, and it is equal to AD squared. AD equals to 3 units, so AD squared is 3 squared, it is 9, plus A squared. Here we have A squared on both sides of the equation, so A squared will get cancelled. And we left only with 1 plus 2A, that is equal to 9. We subtract 1 from this equation, equation number 2, and we get that according to equation number 2, 2A equals to 9 minus 1 is 8. 2A equals to 8. We divide this equation, equation number 2 by 2, and we get that A equals to 8 over 2 is 4. A equals to 4. So here A we found out that a equals to 4, and 1 plus a is 5. In the next step, we'll define angle AED as alpha. So in the right main triangle, triangle AED, cosine alpha equals to ED over EA. Here ED equals to 4 and EA equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. In the next step, I will present to you a new law, and we will implement the new law in this triangle, triangle EBC. The new law is the law of cosines. The law of cosines is true in any triangle. So, according to the law of cosines, if we have triangle ABC, it could be any triangle. This is triangle ABC. We know that the length of side AB is A unit, the length of side AC is B units, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine alpha. This equation is true in any triangle. I will repeat again. According to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine alpha. So we will implement the law of cosines in our triangle EBC. Okay. So here EB equals to A, EB equals to A, and EB also equals to 5 plus 5, that is 10 units. Okay. EC equals to B, and EC is also equals to 4 plus 6, that is also 10 units. BC equals to C, and we already found out that cosine alpha equals to 4 over 5. So, according to the law of cosines, we will get that C squared, C is BC, so it is actually BC squared C squared, C equals to BC, so C squared is BC squared. Equals to A squared. A squared, A equals to EB, so A squared is EB squared. Plus B squared. EC equals to B, so EC so B squared is EC squared minus 2 times EB times EC times cosine alpha. So BC equals to 10, so BC squared is, and then BC equals to C, BC equals to X here, BC equals to X, so BC squared is X squared, and it is equal to EB squared. EB equals to 10 units, so EB squared is 10 squared, that is 100, plus EC squared. EC also equals to 10 units, so EC squared will be equal to also to 100, minus 2 times EB is 10, and EC is also 10, and cosine alpha equals to 4 over 5, so we substitute cosine alpha by 4 over 5. So, in conclusion, we found out that according to equation number 3, x squared equals to 100 plus 100 is 200. 10 times 10 is 100, and 100 times minus 2 is minus 200, times 4 over 5. So, in conclusion, according to equation number 3, we found out that x squared equals to 200 times 4 over 5. So according to equation number 3, x squared equals to 200 minus 200 over 5 is minus 40 times 4. So according to equation number 3, x squared equals to 200 minus 40 times 4 is minus 160. So according to equation number 3, x squared equals to 200 minus 160 is 40. So if we know that according to equation number 3, x squared equals to 40, we take out of this equation, equation number 3, and we get that according to equation number 3, x equals to the square root of 40. 40 is 4 times 10. And the square root of 4 is 2, so in conclusion we found out that x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Okay. I'll repeat again that the length of this line segment BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the length of this line segment BC that is equal to x according to the second method. In the second method, we'll make another construction from point A. We'll draw a straight line on DC in such a way that the straight line will be parallel to BC. We'll define the touching point of the straight line from point A, and DC is E. I repeat again that we draw the straight line AE in such a way that AE is parallel to BC. Okay, here AE is parallel to side BC according to our construction. In the next step, from point E, we will draw straight line on BC in such a way that the straight line will be parallel to AB. Okay? We define the touching point of the straight line from point E and BC as F. I repeat again that according to our construction, EF is parallel to AB. Okay, here, EF is parallel to side AB according to our construction. So actually, quadrilateral AEBF, this quadrilateral has two couples of sides that are parallel to each other. That is to say, AE is parallel to BF and AB is parallel to EF. Therefore, quadrilateral AEBF is a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram, and therefore quadrilateral ABF is a parallelogram. In the next step, I will present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. I read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, side AB is parallel to side EF, AB is parallel to EF, side AB is parallel to side EF. According to our construction, therefore, according to rule number 3, because of the fact that those two angles are defined as corresponding angles and they are located between the parallel lines AB and EF, they are equal to each other. So I write it down, angle ABC equals to angle EFC according to rule number 3. Angle ABC is equal to angle EFC according to rule number 3. Okay? But angle ABC equals to theta according to what is given as the question. So can I write here that angle ABC equals to theta? And from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. So this angle EFC equals to theta. Likewise, according to our construction, AE is parallel to BC. AE is parallel to BC. According to our construction, I'll repeat again, side AE is parallel to side BC according to our construction. Therefore, those two angles that are defined as corresponding angles and they are located between the parallel lines AE and BC will be equal to each other according to rule number 3. That is to say, this angle AED angle AED will be equal to angle DCB and they will be equal to each other according to rule number 3. I repeat again that angle AD will be equal to angle DCB according to rule number 3 because of the fact that those two angles are defined as corresponding angles and they are located between the parallel lines AB and BC. But angle DCB, this angle equals to theta according to what is given as the question. Angle DCB equals to theta, and from this equation theta equals to angle DCB equals to angle AD. We will conclude that angle AED is also equals to theta. So this angle AED equals to theta. Okay. In the next step, I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. The opposite sides of a parallelogram So I read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we will relate to our parallelogram AEBF. Here P is the abbreviation for parallelogram. In parallelogram ABF, according to rule number 4, side AB equals to side EF. Okay, side AB equals to side EF according to rule number 4. But according to what is given as the question, AB equals to 5 units. So we can write here that AB equals to 5 units. And from this equation, 5 equals to AB equals to EF. We will conclude that EF is also equals to 5 units. Here EF equals to 5 units. In the next step, we will focus on triangle EFC. In triangle EFC, we have two angles that are equal to each other. Those two angles, they are both equal to theta, therefore they are equal to each other. So in triangle EFC, we know that angle EFC, this angle, is equal to this angle that is actually angle ECF. And both angles are equal to theta. I'll repeat again. In triangle ECF, angle ECF equals to angle EFC equals to angle ECF, and they are both equal to theta. Therefore, according to rule number 1, side EF equals to side EC. EF equals to EC, according to rule number 1, it says that in front of equal angles in the triangle, there are equal sides. Okay, EF equals to EC, but EF equals to 5 units, according to what is given, according to what we have already found out, EF equals to 5 units, actually according to rule number 4. And from this equation, 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. EC is also equals to 5 units. So here EC equals to 5 units. Okay. So we will focus, but before that, the length of the short line segment DE from the drawing, it is very easy to see that DE equals to DC minus EC. Again, DE equals to DC minus EC. I write it down. DE equals to DC minus EC. I repeat again that DE equals to DC minus EC. It is very easy to see it from the drawing. So DE equals to DC equals to 6 units according to what is given as the question, and EC equals to 5 units. So in conclusion, I found out that D equals to 6 minus 5, that is 1. So D equals to 1 unit. So we can write here that DE equals to 1 unit. So here we have the right triangle ADE. We will implement the Pythagoras theorem on the right great triangle ADE in order to find out the length of the hypotenuse AE. So in the right triangle, triangle ADE, by PT, this is the abbreviation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, according to equation number 1, AE squared equals to AD squared plus DE squared. AE squared equals to AD squared plus DE squared. So AE squared, according to equation number 1, AE squared equals to AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9. Plus DE squared. DE equals to 1 unit, so DE squared is 1 squared, that is also 1. So in conclusion, I found out that according to equation number 1, AE squared equals to 9 plus 1, that is 10. Here we take out of this equation, equation number 1, and we get that according to equation number 1, AE equals to the square root of 10 units. AE equals to the square root of 10 units. You can write here that AE equals to the square root of 10 units. Now we will use rule number 4 in parallelogram AEBF. According to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF according to rule number 4. In parallelogram AEBF, I repeat again that P is abbreviation for parallelogram. According to rule number 4, AE equals to BF. The opposite sides of a parallelogram are equal to each other. According to rule number 4, but A equals to square root of 10 units, so I feel that A equals to square root of 10 units. And from this equation, BF equals to AE equals to square root of 10 units, we will conclude that BF is also equals to square root of 10 units. Here BF equals to square root of 10 units. And what is the length of side FC? From the drawing, it is very easy to see that the length of side FC equals to BC minus BF. I repeat again that BC minus BF equals to FC. So FC equals to BC, BC equals to X according to what is given as the question, minus BF. And we just write down found out that BF equals to the square root of 10 units. So actually, in conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to FC equals to X minus square root of 10 units. Okay. In the next step, we will focus on triangle EFC. This triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC equals to 5 units. So I write it down. Triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC equals to 5 units. For that reason, triangle EFC is an isosceles triangle and FC is the base of the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. In the next step, we will make a construction from point E, the vertex E of the isosceles triangle EFC. We will draw perpendicular on the base FC. Okay. So from point E, we will draw perpendicular on the base FC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction, because this is perpendicular to FC, and we define the touching point of the perpendicular from point E and FC as M. I repeat again that EM is perpendicular to FC, therefore this angle equals 90 degrees and this angle equals 90 degrees according to our construction. So EM is perpendicular to FC. So what is EM? EM is the height to the base FC, because whenever you have line segment that exists from the vertex of a triangle and it is perpendicular to any side of the triangle, it is defined as the height to that triangle. Therefore, EM that is perpendicular to FC, it will be defined as the height to the base FC. So EM is the height to the base FC. So I write it here that EM is the height, line segment EM is the height to the base FC. Okay? And we have rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. I will write it down. The height to the base in an isosceles triangle bisect the base. So I'll read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So actually here, we'll focus on triangle EFC. Here, according to rule number 5, the height EM to the base FC bisects the base FC. So according to rule number 5, the height EM bisects the base FC. It means that it divides the base into two equal parts. So if this part equals to FC over 2, then this part will be also equal to FC over 2. So those two parts are two equal parts. That is to say, FM equals to MC. triangle EFC according to rule number 5, FM equals to MC. Those two parts are equal to each other according to rule number 5. And each part equals to FC over 2. Because of the fact that it divides, the ITM divides the best FC into two equal parts. So if this part equals to FC over 2, then this part will be also equal to FC over 2. So according to rule number 5, FM equals to FC over 2, and MC is also equal to FC over 2. So in conclusion, we found out that according to rule number 5, MC equals to FM equals to FC over 2. So we can, from this equation we will derive that MC equals to FC over 2. We have already found out that FC equals to X minus square root of 10. And if we divide it by 2, we'll get MC. So in conclusion, we found out that MC equals to X minus square root of 10 over 2. Okay, MC equals to X minus square root of 10 over 2. Here, MC equals to X minus square root of 10 over 2 according to rule number 5. In the next step, we will prove that those two right triangles are similar to each other. So we will prove that the right big triangle EMC, the right great big triangle EMC is similar to the right small green triangle ADE. I'll write it down. We'll focus on triangle ADE and triangle EMC, and we'll prove that those two right green triangles are similar to each other. Okay. First of all, in the green right triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right green triangle, angle MEC, this angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, exactly for the same reason, in the right triangle AED, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. So we just right now found out that those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle EDA, this angle equals to this angle, it is actually angle MEC, both angles are equal to 90 degrees minus theta. Therefore, they are equal to each other, of course. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. So angle AED is equal to this angle, this is actually angle MCE, and they are both equal to theta. Therefore, they are equal to each other, of course. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle ADE, this angle, is equal to this angle, this is actually angle EMC. They are both equal to 90 degrees, therefore they are equal to each other, of course. So all the angles, all three angles of this right triangle can go into all three angles of this right triangle. Here, those two angles are both equal to 90 degrees, those two angles are both equal to 90 degrees minus theta, and those two angles are both equal to theta. Therefore, triangle AED, this triangle, is similar, this is the sign of similar to triangle EMC. This triangle EMC according to angle similarity rule. Okay, those two real right triangles are similar to each other according to angle similarity rule. Hence, we derive from it the fact that those two right triangles are similar to each other. That AE over EC is equal to DE over MC. I'll repeat again. From the fact that triangle ADE is similar to triangle EMC, we will derive that AE over EC equals to DE over MC. A equals to the square root of 10 units, EC equals to 5, D equals to 1, and MC equals to x minus square root of 10 over 2. So according to equation number 2, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the denominator. In this set of equation number 2, we will get that square root of 10 over 5 equals to 2 over x minus square root of 10. Here we cross multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 2 times 5 is 10. Here we'll substitute 10 by square root of 10 times square root of 10. And we'll get that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. We divide this equation number 2 by square root of 10, and we get that according to equation number 2, square root of 10 times square root of 10 over square root of 10 is 1. So in this set of equation number 2, we left only with x minus square root of 10, and there square root of 10 times square root of 10 over square root of 10 is square root of 10. Here we add square root of 10 to this equation number 2, and we get that according to equation number 2, x equals to square root of 10 plus square root of 10 is 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Okay, we finish with the second method. Here x equals to either 2 times square root of 10, or in terms of numbers it is equal to 6.32 units. Okay, so in the next step I will summarize the lecture. We'll start with the first method. So I'll repeat on the question. We have here quadrilateral ABCD, side AB equals to 5 units, AD equals to 3 units, DC equals to 6 units, angle ADC equals to 90 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of line segment BC that is actually equals to x. So in the first method, we did a construction. We extended side AB and side CD by a straight line until they intersect with each other at point E. And here we actually created triangle EBC that has two angles that are equal to each other. Those two angles are equal to theta, therefore they are equal to each other. And here I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. That is to say, if you relate to a triangle ABC, in front of those two equal angles, there are equal sides. That is to say, EB equals to EC, according to rule number 1. Because of the fact that in triangle ABC, this is triangle ABC, in triangle ABC, we know that angle ABC equals to angle ECB, and they're both equal to theta. Therefore, according to rule number 1, side EB equals to side EC. But here EB equals to 5 plus AE. EB equals to 5 plus AE, and EC equals to 6 plus ED. EC equals to 6 plus ED. So in conclusion, we found out that 5 plus AE equals to 6 plus ED. We subtracted 5 from this equation, equation number 1, and we found out that AE equals to 1 plus ED. Then we defined ED as A. Here, ED equals to A according to our definition. And we substituted ED by A in equation number 1. And we got that AE equals to 1 plus ED, but ED is A according to our definition. So we substituted ED by A, and we got that AE equals to 1 plus A. Here, AE equals to 1 plus A. So here we have, before we did the construction, we had the quadrilateral ABCD. So line segment DC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. So CD is a straight line, and when we extended the straight line CD by a straight line, the result must be also a straight line, because when you extend the straight line by a straight line, the result must be a straight line. Okay, so therefore CE, it is absolutely a straight line. Okay, CE is a straight line, or EC is a straight line, it is the same. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if you focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have here 90 degrees plus angle ADE. This angle in total, they must be equal to 180 degrees according to rule number 2. I will repeat again. At this side of the straight line ED at point D, the sum of the angles must be equal to 180 degrees. So 90 degrees plus angle ADE, in total the sum of those two angles must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that angle ADE, the missing angle, equals to 90 degrees. So this angle equals to 90 degrees. So if this angle equals to 90 degrees, it means that triangle ADE is a right triangle. So we can implement the Pythagoras theorem on the right green triangle, triangle AED. Okay. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle, the right green triangle ADE, Phi pt is evaluation for Pythagoras theorem. AE squared equals to AD squared plus ED squared. A equals to 1 plus A, so A squared is A1 plus A squared plus AD squared equals to ED squared. ED equals to A, so AD squared is A squared. So conclusion we found out that 1 plus A squared equals to AD squared plus A squared. We open the brackets on this side of equation number 2 and we got that 1 plus A squared equals to 1 plus A squared plus 2A, and it is equal to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus A squared. Here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation number 2, and we found out that 2A equals to 9 minus 1 is 8. So 2A equals to 8. We divided this equation number 2 by 2, and we got that A equals to 8 over 2, that is 4. So we found out here that A equals to 4 units, therefore A plus 1 equals to 5. And then we focused on the right small triangle, triangle AED. The right small green triangle, triangle AED. We defined the angle BEC as alpha. So here cosine alpha in the right green triangle AED, cosine alpha equals to ED over EA. I'll repeat again. In the right small green triangle AED, cosine alpha equals to ED over EA. ED equals to 4, EA equals to 5, so in conclusion we found out that cosine alpha equals to 4 over 5. Okay. Then I presented to you a new rule, and we implemented the new rule in this triangle, triangle ABC. The new rule is the law of cosines, that is true in any triangle. So if you have this triangle, triangle ABC, that could be any triangle, side AB equals to A units, side AB equals to B units, and side BC equals to C units. And the angle between side AB and side AC is alpha. Then, according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. This equation is true in any triangle. So we implement the law of cosines in our triangle, triangle ABC. So in this triangle, triangle ABC, EB equals to A, EC equals to B, BC equals to C, and this is again alpha, of course, and cosine alpha equals to 4 over 5. But EB is not only equal to A, but it is also equal to 5 plus 5, that is 10. EC is not only equal to B, but it is also equal to 4 plus 6, that is also 10. So according to the law of cosines, we will get that C squared is BC squared, and it is equal to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. I repeat again, according to the law of cosines, we will get that BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Here BC equals to x, so BC squared is x squared. EB equals to 10, so EB squared is 10 squared, that is 100. EC equals to 10, so EC squared is 10 squared, that is also 100. Minus 2 times EB times EC times cosine alpha. So this minus 2 times 10 times 10 times cosine alpha, that is 4 over 5. Okay. So in conclusion, we found out that according to equation number 3, x squared equals to 100 plus 100 is 200, and here we have 10 times 10 is 100, and 100 times minus 2 is minus 200. So it is minus 200 times 4 over 5. So here x squared equals to 200 minus 200 over 5 is minus 40, so in conclusion this expression equals to minus 40 times 4. So here, according to equation number 3, x squared equals to 200, and minus 40 times 4 is minus 160. So according to equation number 3, x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, according to equation number 3, we got that x squared equals to 40. We took out of this equation number 3, and we got that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2, so in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Here, x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. Then I presented to you how to find out the length of line segment BC that is equal to x according to the second method. In the second method, we did another construction. From point A, we go straight line on DC in such a way that AE will be parallel to BC. Again, the straight line was done in such a way that AE will be parallel to BC. In the next step, from point E, we go straight line on BC in such a way that EF is parallel to AB. Okay, so here we created quadrilateral BF is a parallelogram. Why? Because it has two couples of sides that are parallel to each other. Then I presented to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF, AB is parallel to EF. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other. That is to say, angle ABC will be equal to angle EFC. So here, angle ABC equals to angle EFC according to rule number 3. But it is given us the question that angle ABC equals to theta. So I can write here that angle ABC equals to theta. And from this equation, theta equals to angle ABC equals to EFC. We will derive that angle EFC is also equals to theta. Okay, this angle also equals to theta. Likewise, according to our construction, AE is parallel to BC. Therefore, according to rule number 3, those two angles that are defined as corresponding angles that are located between the parallel lines AE and BC will be equal to each other. That is to say, angle AED will be equal to angle DCB according to rule number 3. I repeat again that AE is parallel to BC according to our construction. Therefore, according to rule number 3, angle AED equals to angle BCD. Why? Because there are two corresponding angles that are located between the parallel lines A and BC, therefore they are equal to each other. But according to what is given in the question, angle BCD equals to theta. This angle BCD equals to theta. So from this equation, angle AED equals to angle BCD equals to theta, we will derive that angle AED is also equals to theta. So this angle AED equals to theta. Okay, Then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. The opposite sides of a parallelogram are equal to each other. So if we relate to our parallelogram AEBF, this parallelogram, here AB equals to EF according to rule number 4. AB equals to EF according to rule number 4, but AB equals to 5 units according to what is given in the question. So we can write down that AB equals to 5 units, and from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. Here, EF is also equals to 5 units. Okay, then here in triangle EFC, those two angles are equal to each other, they are both equal to theta. In triangle EFC, those two angles are both equal to theta, therefore they are equal to each other. Triangle EFC equals to angle ECF, and they are both equal to theta, therefore, according to rule number 1, that in front of equal angles in the triangle there are equal sides, we will conclude that EF equals to EC. EF equals to EC. Okay, but EF equals to 5 units. We just found out that EF equals to 5 units. So from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. If EC equals to 5 units also. So if EC equals to 5 units and DC equals to 6 units, then the short line segment DE will be equals to DC minus EF. Okay, here DE equals to DC minus EC. I repeat again. DE equals to DC minus EC again. DE equals to DC minus EC. D equals to DC minus EC. DC equals to 6 units and EC equals to 5 units. DC equals to 6 units, EC equals to 5 units. In conclusion, D equals to 6 minus 5, that is 1. So D equals to 1 unit. So D equals to 1 unit. AD equals to 3 units, so we can implement the Pythagoras theorem on the green small right triangle, triangle ADE, in order to find out the hypotenuse AE. Okay, so in the green right triangle, triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE squared equals to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that AE squared equals to 9 plus 1, that is 10. So according to equation number 1, AE squared equals to 10. We took out of this equation number 1, and found out that AE equals to a square root of 10 units. Here, found out that here AE equals to a square root of 10 units. Now we can use rule number 4 in order to find the length of side BF. According to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF. Okay, in parallelogram AEBF, the opposite sides are equal to each other. That is to say, A equals to BF. But we just right now found out that A equals to square root of 10 units. So from this equation, square root of 10 equals to A equals to BF. We will derive that BF is also equals to square root of 10 units here. BF equals to square root of 10 units. Here, BF equals to square root of 10 units. So what is the length of side FC? From the drawing, it is already to see that FC equals to BC minus BF. Again, BC minus BF equals to FC. Here, FC equals to BC minus BF. BC equals to X. BF equals to square root of 10 units. So in conclusion, I found out that FC equals to X minus square root of 10 units. Here, X equals to FC equals to X minus square root of 10 units. Okay. Then we focus on triangle FEC. In triangle FEC is an isosceles triangle because of the fact that side EF equals to side EC equals to 5 units. I'll repeat again. Triangle FEC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. And here, FC is the base of the isosceles triangle, triangle EFC. Then we did the construction from the vertex E of the isosceles triangle EFC. We drew perpendicular on FC. So here EM is the height to the base FC. Why? Because EM is perpendicular to FC. That is to say, this angle equals 90 degrees and this angle equals 90 degrees. Therefore, EM is the height to the base FC. So here EM is the height to the base FC. Okay? Because any line segment that exists from the vertex and is perpendicular to any side of the triangle is defined as the height to the triangle. Therefore, here, because of the fact that EM is perpendicular to FC, it means that EM is the height to the base FC. Okay, EM is the height to the base FC. So then, in the next step, I presented actually rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. Again, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, the height EM to the base FC of the isosceles triangle EFC bisects the base FC. It means that it divides the base FC into two equal parts. That is to say, FM equals to MC according to rule number 5. Here, FM equals to MC. And each part will be equal to FC over 2. That is to say, FM equals to FC over 2 and MC is also equal to FC over 2. Why? Because the height bisects the base. It means that it divides this into two equal parts. So if one part is FC over 2, then the other part will be also equal to FC over 2. That is to say, FM equals to FC over 2 and MC is also equal to FC over 2. In conclusion, FC over 2 equals to FM equals to MC according to rule number 5. From this equation, we will derive that MC equals to FC over 2. FC is X minus square root of 10, so FC over 2 equals to X minus square root of 10 over 2. So in conclusion, we found out that MC equals to X minus square root of 10 over 2. Here, MC equals to X minus square root of 10 over 2. Then we proved that those two main right triangles are similar to each other. But first of all, in this green right triangle, this angle equals to 90 degrees. This angle equals to theta, so this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right triangle to 180 degrees, this angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, this angle must be also equal to 90 degrees minus theta. So here, those two triangles, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, angle EDA equals to angle MEC, they are both equal to 90 degrees minus theta. In addition, those two angles they are both equal to theta, therefore they are equal to each other, and those two angles they are both equal to 90 degrees, therefore they are equal to each other. So actually, in conclusion, we found out that all the angles of triangle AED correspond to all the angles of triangle EMC. Therefore, triangle AED is similar to triangle MEC according to angle similarity rule. And from that fact, we will derive that AE over EC equals to DE over MC. Here, AE over EC equals to DE over MC. Okay, AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator, and found out that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Because multiply this equation number 2, and we found out that according to equation number 2, square root of 10 equals to x minus square root of, according to equation number 2, square root of 10 times x minus square root of 10 equals to 10. Then we substituted 10 by square root of 10 times square root of 10. And we found out that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. We divided this equation number 2 by square root of 10. And we got that according to equation number 2, in this side of equation number 2, square root of 10 times square root of 10 is 1. So we left only with x minus square root of 2. And here on the other side, square root of 2 times square root of 2 over square root of 10 times square root of 10 over square root of 10 equals to square root of 10. So in conclusion, we found out that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation number 2, and we found out that x equals to square root of 10 times square root of 10 is 2 times square root of 10. So x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So here, x, the length of line segment BC that is actually equals to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So in both methods, we arrive to the same result. Okay? Thank you very much.